Good day to Dr. and my fellow friends. I am Victor Yometek, metric number AF200134. We are from Group 7 for the subject Water System Design and Management. My group members consist of Wu Yuting, Izato Aisha binti Mat Saleh, Muhammad Shiz Daniel bin Alias, and the last one is Shifa Nazira binti Muhammad Jali.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shiz Daniel bin alias AF200008. Today I'm going to talk about our project overview. So this is our project signboard which is located at Lot 12100 Klebang, Melaka with a three-phase project. The first phase consists of 43-story condotel B with 629 units and 41-story condotel C with 529 units, a 1.5-story shop, a 2-story pencawang pembahagian utama or PPU, 1 unit, and a 2-story main switching station, SSU, 1 unit. For the next phase is a 11-story hotel with consists of 270 rooms, and the last phase of this project is 43-story condotel A with 578 units. Objective of our project is to design a sewage system and sediment basin that is suitable for the project. For sewage system, the population of the study area and the size of the elevated tank are calculated, which they are needed to fulfill the demand of the area. We use dry weather flow of 225 liter capacity per day that is from MSIG by SPAN, Volume 3 in Section 2. You can see the full design of our sewage reticulation from the project report in Chapter 2. For sediment basin, the design of our project is based on Urban Storm Water Management Manual for Malaysia, MASMA 2nd edition. We refer the section 12.4.4.4 in page 361, and we use the table 12.16 until 12.19. You can see the full design in our report in chapter 3.
Assalamualaikum and good day. My name is Satisha Binti Masadi, number matric AF200062. I will present for part design sewerage reticulation. This picture shows the arrangement of 5 manholes that connected from residential and other premises to STP. So the catchment area is 96072 meters square, and the diameter sewer pipe that we suggested is 250 millimeter, and the type pipe is we use ductile iron. So in this area we have conductor A 578 unit, conductor B 329 units, conductor C 539 unit, and hotel 270 units. So the length for manhole 1 to manhole 2 is 72 meter, manhole 2 to manhole 3 is 6 meter, manhole 3 to manhole 4 is 48 meter, and the manhole 4 to manhole 5 is 36 meter. Next, the calculation of design sewer manhole 1 to manhole 2. The first step is to calculate the population in pipeline. For manhole 1 to manhole 2, it achieves sewage only from conductor B. So the population is 3,145 PE, which the 629 units times 5 per house. Why we multiply fast? Because as referred table for population equivalent regulated as shown at left side. For the residential, the total of units house must multiply with 5. So we got the population equivalent for the conductor B. This table we can refer in Malaysian Sewerage Industry Guidelines Volume 4 in Section 1.5.
Bismillahirrahmanirrahim. My name is Shifana Zira binti Muhammad Ali. So today I will continue with the calculation design survey from manhole 1 to manhole 2. So we start with the dry weather flow, which is DWF. So to get dry weather flow, we use formula DWF times PE. The PE that we have is 3,145. After we times the DWF, we get 8.19 liter per second. So the value of dry weather flow is 225 liter per cap per day as referred in Malaysian Sewage Industry Guideline, which is MSIG Volume 3 Section 2.114. So we continue with the peak flow factor. We use the formula peak flow factor to get a peak WF. So after we use the formula peak flow factor, and we get peak WF. So the peak DWF that we get is 33.94 liter per second. So the diameter that we use in this calculation is 0.25 meter running in full pipe flow. As referred in SIG Volume 3 Section 2.1.7, the ductile ion pipe manufactured in Malaysia for diameter from 80 mm to 1,200 mm, and the minimum diameter pipe public gravity seaway is 225 in MSIG Volume 3 Section 2.117. It shows that design diameter of our seaway purposes is acceptable. So we continue to calculate the area, weighted parameter, and the hydraulic gradient from the diameter that we have, which is 0.25 meter. So after we calculate all these three, we continue to calculate the gradient. The gradient is a 0.01, and we continue with the velocity. So the answer for the velocity that we calculate is 1.07 meter per second. So which is the velocity in our calculation is in a range between 0.8 until 4.0 meter per second. So which is the velocity is okay. So we continue with the length of seaway. So in MSIG Volume 3 Section 2.2.2 state that spacing between manhole should not be more than 100 meter for seaway less than 1.0 meter in diameter. Therefore, the length of seaway pipe is 72 meter is acceptable because under the range 100 meter. So we continue with the to calculate fault, ground level, upper inlet level, average depth, and lower inlet level. So we get the answer for the fault, ground level, upper inlet level, average depth, lower inlet level. We make a conclusion, which is the ductile iron seaway with diameter 250 mm is appropriate to handle sewage from 3145 PE because velocity is 1.07 meter per second with the sediment cleansing velocity 0.8 to 4.0 meter per second. And the WPF of maximum flow rate is bigger than the peak WPF, DWF, sorry.
Now it's my turn to present the design for the sediment basin. The picture beside clearly shows that the layout plan of our constructions area. The location of the sediment basin is located near to the conductor A. This sediment basin is located near to the stream which stated in MASMA 2nd editions chapter 12.4.4.4.
Salam Doctor, my name is Ying with metric notes at F200155. Today I'm going to present about the sediment design. Firstly is the determinations of type of soil. Based on the doctor requirement, in this report we are using the dry basin type. But according to the MISMA second editions, chapter 12, table 12.16, sediment type and design considerations. In the table, we can figure out the category of our type of soil, which is category 1, and the soil description is coarse grain. Next is basin design parameter. The side runoff potential in this report is very high runoff, and the design storm event is equal to 50 millimeters. And by according to the MISMA second editions, table 12.19 shows that the surface area is equal to 340 meters square per hectare, and the total volume is equal to 510 meter cube per hectare. Area in this project is 9.6 hectare. Then the calculated surface area required is equal to 3,264 meters square, and the total volume for basin required is equal to 4,896 meter cube. Next is the sediment basin design. Firstly is the settling zone. The required settling zone depth is the half of the total volume, which is 4,896 divided by 2, and then we get 2,448 meter cube. Then for the selected settling zone depth is equal to 0.9 meter, which match the criteria design of sediment basin shows in MISMA second editions table 12.17, shows that the minimum depth of settling zones is equal to 0.6 meter. Also for the settling zone width is equal to 30 meter in this project. Then the required settling zone average depth can be calculated by using formula V1 equal to W1 times Y1 times L1, and the L1 is finally get is 90.7 meter, which approximate to 91 meter. Therefore, the average surface area in this project is equal to 30 meter times 91 meter. Also, the checking requirement is needed since the L1 divided by Y1 is smaller than 200 and L1 divided by W1 is larger than 2, so the value of L1 is considered okay. According to the MISMA second editions, table 12.17 shows that the ratio of side slope is equal to 2 horizontal and 1 vertical. And the dimension of top of the sediment storage zone area are W2 equal to 29 meter and the L2 equal to 90 meter. The required depth of the sediment storage zone, which must be at least 0.3 meter, can be calculated from the following relationship and also by using the trial and error method. The Y2 equal to 1.1 is larger than 0.3 meter and the V2 equal to 2,588 meter cube, which is larger than the 2,448 meter cube. Since the design for sediment storage zone is considered okay. For the overall basin dimensions, for base, the width of base is equal to 24 meter and the depth of the base is equal to 84 meter. And also for the depth, the settling zone Y1 equal to 0.9 meter, sediment storage zone Y2 equal to 1.1 meter, and the side slope ratio is equal to 2 horizontal and 1 vertical.
According to MASMA second editions, the runoff quantity must be measured up to 10 years ALI. To determine the runoff quantity on 10 years ALI, we must refer to the MASMA second editions chapter 2, table 2.5. The station of Bukit Sebungo is selected because this station is near to our constructions area. By using the equations that stated, the rainfall intensity that calculated is 131.85 millimeters per hour. Rational method is used to calculate the peak flow for 10 years ALI. The equations 2.3 that stated in MASMA second editions, it is a rational method. This equation is Q10 equal to CIA divided by 360. The I is the rainfall intensity that we calculated before, while the A is the contributed area, which mentioned in MASMA second editions table 12.17, which stated that the minimum contributing area must be 2 hectare. For our construction area, it is 9.6 hectare. The coefficient of the runoff C is assumed as 0.5. With referring to the MASMA second editions, chapter 2, table 2.6, we selected the open space, no cover, and 10 years ARI, which the value for the runoff coefficient is 0.5. Based on MASMA second edition's table 12.17, it stated that the riser and the spillway are required to install at the sediment basin to control the runoff. Equation 2.6 that provided in mass second editions is to determine the flow rate of the riser. The flow rate of the riser Q riser is equal to the C naught Air naught Cert 2G H naught. The diameter of the riser is assumed as 0.85 meter and the heat is assumed as 0.7 meter. The Q riser that we calculated is 1.26 meter cube per second. To calculate the flow rate for the spillway, the flow rate for 10 years LI must be subtracted by the flow rate of the riser to obtain the flow rate of the spillway. The flow rate that required for the spillway is equal to 0.5 meter cube per second. Equation 2.1 that provided in mass second editions is to calculate the flow rate of the spillway. The equation is shown as Q spillway equal to CSP B HP power 1.5. In this project, the width of the spillway is assumed as 0.6 meter and the heat is assumed as 0.7 meter. Based on mass second editions, chapter 2, table 2.7, the CSP obtained is 1.65 meter. By substituting this value into the equations, the Q spillway that we obtain is 0.58 meter cube per second, which is greater than the Q required that we calculated before. The total basin depth that included the spillway is equal to Y1 plus Y2 plus heat of riser plus heat of the spillway. The total basin depth that we obtain is equal to 3.4 meter. According to the mass second editions, chapter 12, table 12.17, the trapping efficiency for the sediment basin is 90%. The sediment storage area for the basin is 2,448 meter cube. It requires 63 events of the same magnitude to fill up the sediment storage. It is calculated by dividing the total volume with the ton of the sediments. We get the 63 events for 3 months ARI. Therefore, 1 year consists of 4 times of 3 months. Hence, the 63 is divided by 4. So we get 15.8 years, which equivalent to 16 years to do the maintenance. The maintenance shall be done after the 63 events of rainfall, and it shall be itemized in the bill of quantity. The bill of quantity design shall be submitted for the authorities' approve. The picture clearly shows that the layout plan of our sediment basin. The sediment basin is in 91 meter length and 30 meter width. The settling zone depth is 0.9 meter and the storage zone is 1.1 meter. The heat of the riser and the heat of the spillway is equal to 0.7 meter. That's all for our group presentation. Thank you.